Welcome to this Edgenexus video on our new HA Cloud Connector app for Azure and AWS. By default, load balancers within cloud infrastructures such as Azure and AWS cannot run as HA pairs due to networking restrictions imposed by the cloud vendors. The HA Cloud Connector is designed to work alongside the cloud's management systems using API calls and can switch the elastic IP from one ADC to another without any manual intervention should virtual service failures occur. One of the main issues of ADCs in cloud locations, such as Azure and AWS, is the single point of failure. Although we have never experienced such failures, this can never be taken lightly. To achieve resilience, you require two ADCs in a high-availability cluster. You would think that two Edgenexus ADCs in an HA cluster would be the way out. Well, in a LAN network, or a private network in a data center, the ADCs will detect themselves. The cluster will be formed using a simple drag-and-drop action, automatic configuration synchronization will be enabled, and failover will be seamless and almost instant. However, when it comes to the public cloud, things are just not so easy. Forming a cluster of ADCs in the cloud presents challenges due to network fabric restrictions. Broadcasts are blocked in cloud networks. To counter this, the Edge ADC uses unicast and multicast for cluster formation and synchronization, and is remarkably straightforward, mirroring the ease of a standard network. Clustering is not high availability, and to achieve HA efficiently more is required, and this is where HACC comes in. The cloud's network fabric design limits what users can do, and it is very strict with this. This is done to avoid serious issues that may be caused, especially as there are thousands of customers using many virtual machines each. The ability to create an ADC-HA pair in the same way we would have done in a LAN or private network is not possible. Cloud suppliers like Azure and AWS have their own ALBs, or application load balancers. Should a cloud-supplied ALB fail, the cloud system will automatically spin up another to take over, albeit with a delay. That said, they are very expensive in terms of data throughput costs. The solution to having a HA pair of Edgenexus ADCs is our new HA Cloud Connector. This is a containerized app that resides securely within the Edgenexus ADC appliance and is available from both Azure and AWS. We will call it HACC from now on. So let's look at the HACC deployment architecture and see how HACC works. The diagram on the screen shows how HACC is configured in terms of networking within the ADC. We have two ADCs that will operate as an HA pair. These are called Instance 1 and Instance 2. Each ADC instance is configured with two network interfaces. Let's call them NIC1 and NIC2. NIC1 on each ADC has a cloud public IP address associated with it. This address is used to administer the ADC. NIC2 on ADC1 has a private IP address with a cloud elastic IP attached to it. This elastic IP address is the one that is used for public access. NIC2 on ADC2 is left as is, and it is to this network interface that we will switch the elastic IP. To summarize, when ADC Instance 1 fails in any manner, the elastic IP will be switched over to ADC Instance 2, seamlessly. The HACC can also be configured to fail back automatically on proper resumption of ADC Instance 1. Now that we have detailed how it works, we can see how it is configured. The HACC is integrated into the cloud versions of the Edge ADC, so unlike other apps, it does not require download and installation. All we need to do is make it operational and then use it. The first step is to provide a container name, IP address, and port. The container name is like a host name and can be anything you wish with no spaces or symbols. The IP address is the private IP address that was allocated to NIC1 of the ADC instance. The port should be specified as 5005/TCP. Now press update and the HACC app is ready to go. You can see this by the stop icon turning red, indicating that it is ready to be launched. To launch the app, click the play icon. The app will launch and the play icon will turn green. You will also see the add-on GUI button where you can access the user interface to configure the app. On the right side, you will see internal configuration details including the parent image name, the IP address used by REST API for internal communications, and the date the app was last started and stopped. There is also the ability to export the configuration of the app and then import it back if required. This is particularly useful should you wish to keep a backup of the configuration. Let's open the user interface by clicking the Add-on GUI button. We now see the login dialog where you must provide the admin credentials in order to continue further. The default username and password are both admin, and you can change them from within the GUI. The administration guide provides details on how to do this. Once logged in, you will be presented with the main services page, which, as you can see, is blank. We are not going to fill in this page right now. Instead, we will be configuring the Cloud Connections section. Click on Cloud Connections. You will be presented with a choice of AWS or Azure. We will be showing you an example of an Azure configuration. It's important to note that this video will not cover the configuration of Azure instances or the preparation of Azure for HACC failovers. These topics are comprehensively explained in the admin guide. Click on Add Cloud Connection and proceed to fill out the details required in the various fields. The Cloud Connection field should contain a descriptive name using alphanumeric characters. The region field should contain the region in which your ADC VMs are located. The subscription ID is available from the Azure VM Overview page. The tenant ID is found in the Azure App Registration Overview when you registered the HACC app. The client ID also available in the Azure App Registration Overview. And finally, the client secret, which you will have noted down when you registered the HACC app. Once you have entered all the required values, click the Apply Changes button to save the settings. The final task in the Cloud Connection settings is to test the configuration. Click the Test button. If all is well with the configuration, the test will show as passed. The next stage in configuring HACC is to configure the destinations. Fill out a descriptive name for the destination field. For the Cloud Connection, drop the menu and select the Cloud Connection you have defined. For the Instance field, select the VM1 instance. From the Network Interface dropdown, select the NIC2 interface on VM1. Click Save. You now have to configure the second definition. To do this, repeat the steps we just did. A descriptive name for the destination. But this time, change the following. Set the Cloud Connection value, and then set the instance to the VM2 instance. Finally, select the NIC2 interface on VM2 from the Network Interface dropdown. Click Save. What you should see will be something like this, with two destinations defined. The first one is the primary ADC instance, while the second is the secondary failover instance. Next comes the definition of the monitoring service. Before proceeding, you should read the admin guide, particularly the sections on setting up ADC networking and the monitoring virtual service. The monitoring virtual service is a primary component of the failover system that is used to check status of the real server by monitoring it continually using the specific virtual service you defined in the ADC. As you can see, it's an additional virtual service that, in our example, connects to port 80 of the real server. The port may differ from what you use, but it works in the same manner and will detect whether the real server is reachable. Click on the Services option on the navigator. This will open up the blank Services panel, as we currently see on screen. Click the Add Service button. The form you see will look like the one on screen, and as you can see, there are a number of fields that require information to be filled in. Let's go through the form. First, select the virtual service you created and set aside for monitoring. Next, select the cloud connection. Then, select the public elastic IP address you created. Now set the preferred destination to instance 1. Next, set the second destination to instance 2. Finally, set the failback to enabled or disabled. If the failback is enabled, then the system will fail back to the primary ADC once services are restored. If it is set to disabled, the elastic IP will remain connected to the secondary, even though the services have returned to availability. Once you have clicked the Save button, you will have completed the configuration, which will look like something in the image you can see. That's it. A proper and successful configuration will be indicated by the green indicator. Please note that you must replicate these configurations on the HACC app on the secondary ADC. To summarize, we will quickly go over how HACC works in practice. On the screen, you can see a typical HACC and ADC layout for Azure. The HACC deployment in AWS will look very similar. When a user connects, they are linked to the ADC instance 1 via the elastic IP, specifically to NIC2. From there, the user's requests are load balanced to the two web servers by ADC instance 1. In this next image, we can now see that something has changed. ADC instance 1 has failed, and the elastic IP has been switched to ADC instance 2, thereby maintaining the connection to the real servers. Thank you for watching this video on the new HACC Cloud Connector by Edgenexus, and if you have any questions, please feel free to contact us.